myself while things are loading. My name is Julie Pisani. I'm the program coordinator with the Regional District of Nanaimo's Drinking Water and Watershed Protection Program. And I'm going to start off my presentation, or conversation, I guess I was about to say, with an introduction on our program that we have with the Drinking Water Watershed Protection Program at the RDM. Then I'm going to talk about the specific monitoring program that we engage with volunteers on in the Englishman River watershed and other watersheds across our region. Talk about a 7-year analysis that was just completed on this data set of surface water quality data, and then I'm going to wrap it into next steps and where to go from here. So our program, this is where I'm going to have more time to speak to this tomorrow in Module A on our Drinking Water and Watershed Protection Action Plan. So the real condensed version is that this is a strategy and a plan that transcends political boundaries across the region to look at strategies for water sustainability at the watershed and aquifer scale through partnerships and collaboration. The 3 main elements of our action plan are education, so that foundational piece of understanding our water resources and our watersheds, and then layering into that the science, the data collection, the monitoring, the better resolution understanding of our local water resources, so that can flow into this 3rd element, which is planning and policy support for water sustainability in the region. So I'm going to speak about, oh geez, I should be looking behind me here. Thanks, Joe. Like, oh, things are going to plan, everything looks good. And I get extra time, right, Pete? Yeah, all right, no business here. No, I'm not in business, now I'm back. Okay. You know, see, this is what we get for being early adopters. You know, there's hiccups along the way, but you must persevere, right? So, to flashback, speaking about our action plan, and now I'm going to flash forward to just speak about the science component of our drinking water and watershed protection action plan. And a specific component, we have many different initiatives that fall under our science branch of our program, but today I'm going to be speaking specifically about the surface water quality monitoring program, our community watershed monitoring network. So the coolest notes on this network, it was established in 2011, and this was in partnership very closely with the Ministry of Environment, who helped us select what are the key parameters to monitor within surface water bodies across our region to get a baseline understanding of watershed health. And so the parameters of dissolved oxygen, temperature, conductivity, and turbidity were selected as parameters to monitor with the help of volunteer stewardship groups that are trained to provincial protocol to collect this data within our region's watersheds. We use provincial protocol insofar as that we have sort of their 5 and 30 data collection standards, which means 5 samples within a 30-day period within the low flow summer period, and 5 samples in 30 days in the fall flush period. So as of right now, we have 62 active sites and 13 trained volunteer stewardship groups. And this is coordinated through the RDM's Drinking Water and Watershed Protection Program with our amazing staff. We have Lauren Fegan, Phil McCallum, and Capri Brugge in the audience today, and I'll give a shout out to them at this point too. And the key thing to underscore here is that we're using provincial protocols, which lends credence to the program, but also, very importantly, the data that's collected is then input into the Ministry of Environment's EMS database, their Environmental Management System database. So the data that's collected by stewardship groups within the region, and many stewardship groups representation I see in the audience today too, so shout out to all those amazing volunteers at this juncture too. This is readily available within provincial databases that are public, open source, and they're mapped readily for folks to access. And I also want to point to the other partnership that's really important in terms of upper watershed land access provided by Mosaic Forest that gives access to monitoring the upper watershed sites. So that's a little bit on the program. I'm going to speak to the sites that are monitored, in particular, yeah, it's working, the Englishman River within our region. So this map really quickly shows the regional district of Nanaimo. We have what we call water regions, 7 of them, a basin scale sort of footprint of areas where we do our watershed planning. And in particular, the Englishman River is water region 4. And I've circled here the sites that are monitored within the Englishman River water region as part of our community watershed monitoring network. And importantly, we'll zoom back out, Mid-Vancouver Island Habitat Enhancement Society, that Pete represents. They're the citizen scientists and the dedicated volunteers that do the sampling within the Englishman River. So here's another look, and it'll load for a second, but here's another look at the watershed, but this time the colors are representing land use. So when I first started talking about water quality and the parameters that are sampled, now I'm kind of overlaying, okay, what are the land use conditions within the watershed? And you can see there's sites on Shelley Creek, Englishman River, Center Creek, Morrison Creek, and Swain Creek that are monitored in this water region. And the colors, and I'll show you the next graph, will show it better as well. But you can see in the upper reaches of the watershed, green for forest use, and then as you move downstream, there's more rural residential and agricultural use, and then there's more urban developed areas, impervious surfaces, as well as you move into the towns downstream. So here's those colors, kind of now grouped in a graph that shows percentage of watershed area for each of those sample sites based on their land use type. So if I go through it really quickly, of course, the green again is the forest land use within the majority of the watershed areas for the Englishman and some sites on Swain Creek and Morrison Creek. But keep in mind, this is based on where the point in the creek that the sample is being taken. If you look upstream in that entire area of land that drains to that sample point, this is the percentage breakdown of the land use categories upstream of that point. Now you'll see in Shelley Creek, and some of you went out there yesterday on the field trip, more agricultural land base, more impervious surfaces as there's more highway corridor and roadways, paved roadways, and more residential areas within that small tributary to the Englishman River and its watershed. So now that we know the sites, I'm going to go into, very quickly, the analysis that we were able to complete. In 2018, last year, thanks, my blood sugar's been low, so I'm glad they're on hand. Very quickly, so we have a 7-year data set. It's great to collect data, but the next step is interpreting that data, finding meaning in the samples and the data that have been collected by our dedicated volunteers throughout the years. So, 3 main questions were asked of this regional analysis of the data. Are we observing changes over time? Are we observing frequent exceedances of the provincial water quality objectives and guidelines? And are there actual statistical predictors that can predict when land use is of a certain composition, and that then predict water quality results in our creeks and streams? So I know I'm going over, but it's just so worth it, Pete. Come on. Okay, so for statistical modeling, thank you for your indulgence. Statistical modeling revealed that land use types associated with human disturbance were important predictors of water quality. So not a surprise, but now it's quantified in a way that's specifically showing the fingerprints of the watersheds that we're monitoring. So categorically, watersheds that were less than 60% forest land use were associated with changes in turbidity and conductivity. Watersheds with less than 20% greater than 20% agricultural use were associated with higher turbidity, so the particle matter, cloudiness, sedimentation, indicator of erosion within the water quality, and lower dissolved oxygen. Paved road densities that are greater than 0.002 meters per meter squared associated with increased conductivity and higher water temperatures. And I won't get into this in detail because I'm getting short on time, but these were the results in particular for the Englishman River and the sites that were monitored there. In terms of turbidity, 2 things that stood out were in the Swain Creek and Shelley Creek watersheds. Again, higher representation of agricultural land use and impervious surfaces above guidelines. Close to guidelines, but not exceeded, were temperatures, so again, an indicator of riparian cover, but also of changing climates and hotter temperatures that we are observing within the summer months. And conductivity, harkening back to Gilles' presentation, talking about the groundwater influence within our creeks and streams, monitoring conductivity as an indicator, and beyond just the Englishman River, which we know we can quantify groundwater influence, we're starting to see, or through the data, we can see indicators within the smaller creeks as well. So higher conductivity values suggesting groundwater influence. So last slide, thank you. So all of this data, of course, making meaning of it, trying to find patterns, trying to have interpretation that can then give us material to inform next steps at the local government level, but also at the stewardship group level, and beyond, advocating with senior government and other agencies as well. Sampling for additional parameters. So this helps us focus where are there areas where we are seeing changes over time or frequent exceedances. And let's get to the bottom of the source of these issues. So we're going to be doing more lab analysis for things like phosphorus indication of agricultural runoff. Also benthic invertebrate monitoring, which was mentioned by Bill Darien in the earlier presentation as well. Support for streamside vegetation, which is already going on in a lot of the creeks and streams, and then supporting the green infrastructure piece. So I'll just conclude by saying, if we build in the community engagement, we build in the data, then that gives us the ammunition, so to speak, to proceed with innovative planning and policy that has community engagement as its very foundation, science as a key ingredient, and that can help us move forward with next steps to improve water sustainability in the region. Thank you, everyone, especially Pete.